Hi children, today we are going to start with the second lesson of factorization. Hope you have enjoyed my first lesson. In previous topic, we have discussed how to factorize a basic algebraic term. Today we are going to extend our knowledge into how to factorize an expression with 4 terms. Before we start up with any proceeding, first we have to see whether is there any common terms available for all the terms in the expression. That is our first step of factorizing. Then if you move up to the second step, if you get expression with 4 terms, first isolate these 4 terms into 2 terms each and see whether are there any common terms available for those pairs. If you refer to this question, the question is to factorize AP plus AQ plus BP plus PQ. Then if you couple these terms AP, AQ separately and BP, BQ separately and see whether are there any common terms available for these expressions. Sometimes you may compare these terms in a way AP with BQ and AQ with BP doesn't matter. Most of the situations, whatever the way we pair, you may get an answer. If you do not receive any answer, shuffle these terms and see whether with another pair. From these terms you can understand that from AP and AQ, A is common and from BP and BQ, B is common. If you take A out from first 2 terms, you can get A times of P plus Q, and if you take B out from second 2 terms, you can get B times of P plus Q. Therefore, you can understand that P plus Q become common again for this expression. Then if you take this P plus Q out, you can see that P plus Q into A plus B, it is the complete factorization of the first term. Now let's try to work out with another example. We have to factorize AP minus AQ and BP minus BQ. As following up the previous steps, I can isolate AP minus AQ separately and BP minus BQ separately. You need not to follow up the step 1 because we can observe that there are no common terms for all the 4 terms in this expression. Therefore, if you isolate AP minus AQ and BP minus BQ, you can understand that A is common from the terms AP minus AQ and B is common from the expression BP minus BQ. If you take A out from first 2 terms, you can understand that it turn up into A times of P minus Q. Then if you take B out from second 2 expressions, it will turn up into B times of P minus Q. Now you can understand that P minus Q again common for these expressions. Therefore, if you take P minus Q out, the term completely get factorized in a way P minus Q times of A plus B. Now let's try to work out with little bit of an advanced question. The question is to factorize 6AP plus 2AQ plus 3BP plus BQ. First we isolate 6AP plus 2AQ, then 3BP plus BQ. If you expand the first 2 terms, you can understand that 2A is common from second expressions, B would be common. If you take 2A out of the first 2 expressions, turn up into 2A times of 3P plus Q, then if you take B out, there itself you can observe it turn up into B times of 3P plus Q. Now 3P plus Q become common for these 2 expressions. If you take 3P plus Q out, it turn into 3P plus Q times 2A plus B. That would be the entire factorization for the expression 6AP plus 2AQ plus 3BP plus BQ. Let's move to the next question. The question is to factorize 8AP plus 2AQ minus 4BP minus BQ. You can understand there are no common terms available for all 4 terms in this expression at once. Therefore, I will isolate first 2 terms and second 2 terms from this expression. If you get first 2 terms 8ab plus 2aq, you can understand that 2a is common. From second expression minus 4bp minus bq, you can understand that minus b is common because both the terms contains a minus b. If you take these terms out, it turns up into 2a times of 4p plus q minus b times of 4p plus q. Again 4p plus q become common. If you take 4p plus q out, you can understand that the expression turn up into brackets 4p plus q times of 2a minus p. This is the first step of factorizing a quadratic expression. If you isolate the terms x squared plus 3x and 2x plus 6 and see whether the availability of finding common terms. From first 2 terms you can see x is common. From second 2 terms 2 is common. If you take x out from first 2 terms, it turns into x times of x plus 3, and if you take 2 out from second 2 terms, it turns into 2 times of x plus 3. Now you can understand that x plus 3 become common. If you take x plus 3 out, it turns into x plus 3 times of x plus 2. Let's try to factorize this example. X squared plus 4x minus 3x minus 12. The first step is to identify any common terms for all the terms in the expression. We can observe that there are no such terms. Therefore, we isolate the terms in this expression. If you isolate these terms, it turns into x squared plus 4x and minus 3x minus 12. From first 2 terms you can see x is common, and from second 2 terms minus 3 is common. If you take x out from first 2 terms, it turns into x plus 4, and if you take minus 3 out from second 2 terms, it turns into minus 3x plus 4. Now x plus 4 become common again. Therefore you can write x plus 4 times of x minus 3 is the complete factorized form of x squared plus 4x minus 3x minus 12. I made this question a little harder. Our objective is to factorize 10x squared plus 8x plus 15x plus 12. If you follow up the steps, I have isolated the terms 10x squared plus 8x and 15x plus 12 separately. With that, you can understand that there would be common terms from 10x squared plus 8x are 2x, and the common terms from 15x plus 12 are 3. As a result, if you take 2x out from first 2 expressions, it turns up into 2x times of 5x plus 4. If you take 3 out, it turns into 3 times of 5x plus 4. Now you can understand that 5x plus 4 common again. If you take 5x plus 4 out, you can say that the complete factorization form of 10x squared plus 8x plus 15 plus 12 would be 5x plus 4 times of x plus 3. Hope you have understood the topic. Now see whether can you obtain the answers in front by factorizing the expressions given over here.